So the first topic I want to discuss today is the inverse of trigonometric functions. So inverse of trig functions. So we start with sine. So f of x is equal to sine. And I restrict the domain to be x between minus pi half and pi half. Then on this interval, the sine function is 1 to 1. So let's look at the graph of the sine. So this is 1 and minus 1, and then you have okay, so this is the y-axis and this is the x-axis. So it goes up and then down, and then up and down. Okay. Okay, so imagine this is the graph of sine, and we restrict the domain between pi half and negative pi half. So on this domain, what is the point pi half? Pi half is this point. And negative pi half, of course, is here. So it's the point minimum and maximum points respectively. And on this domain, you can see that the function sine is invertible. It's 1 to 1. So I just erase everything. So that means I restrict the domain to be in this interval. Okay. So you see in this interval, the sine is 1 to 1, is invertible. So I defined the inverse to be f inverse of x. We call it arc sine. So, and by the definition, we know that y is equal to arc sine if and only if x is equal to sine of y. So these are inverse of each other. Okay. So that's basically the definition of arc sine. So for instance, we know that sine of 0 is 0. So arc sine of 0 is also 0. Sine of pi half is 1. So arc sine of 1 would be pi half. Or sine of negative pi half is negative 1. So arc sine of -1 is -pi². So you can make a table of these values. So on the first row, you have x and then arc sign. So for 0, we know that arc sign of 0 is 0. Arc sign of, what is arc sign of 1/2? Can someone tell me the arc sign of 1/2?
Pi.
Pi over
Pi over
6.
6. And then arc sign of -1/2 is -pi over 6. And by the way, it's an odd function because sine is also odd. So arc sign of 1/2 is pi over 6. Arc sign of -1/2 is -pi over 6. And we also have like the numbers like √3 over 2. The arc sign of √3 over 2 is pi over 3. And then the arc sign of 1 is pi². And the arc sign of -1 is -1 pi². These are just sample values for the function arc sign. Okay. So similarly, I can define like arc cosine. But for arc cosine, if I have f of x equal to cosine of x, I restricted the domain between 0 and pi. So for cosine, I restrict the domain between 0 and pi and define the inverse to be called arc cosine. And by definition, y is equal to arc cosine of x if and only if x equal to cosine of y. So you can make a similar table for some values of arc cosine. And by the way, the domain of both the domain, the range of the function sine and also cosine are -1 to 1. So that means the domain of the inverse, arc cosine and arc sine, is -1 and 1. So the domain always for arc cosine and arc sine, the domain is between -1 and 1. Okay, now what is the arc cosine of 1? So what is the arc cosine of 1? So what angle is
Pi.
no 1? What is the angle whose cosine is 1? And it has to be
0.
between 0 and pi. Yes, it's 0. It has to be between 0 and pi, and this is very important. Okay, because you can also say, okay, 2 pi is also a possibility because cosine of 2 pi is also 1. Cosine of 4 pi is also 1. But I want to restrict between 0 and pi. Okay, so how about 1/2? So what is the angle whose cosine is 1/2? The angle has to be between 0 to pi.
Pi over 3.
Pi over 3, perfect. And how about 0?
Pi over 2.
Pi over 2. How about, I don't know, 1/2.
Two pi over 3.
Okay, so that's good. So minus pi half, it should be 2 pi over 3, which is pi minus pi over 3. Exactly. And minus 1 is, of course, pi. Okay. So for arc sine and arc cosine, you just switch the x and y values of sine and cosine respectively, right? And similarly, you can do the same thing with tangent and cotangent. I just write tangent. So f of x equal to tangent of x. And I restrict the domain between minus pi half and pi half. So I call the inverse of this function arctangent. So that means by definition, y is equal to arctangent of x if and only if x is equal to tangent of y. So for this also, you can make a table of some values. So here is x and arctan x. So, but here, the range of tangent between minus pi half and pi half is it's the whole real numbers. It's from minus infinity to infinity. Let us look at just the tangent function, because it has two vertical asymptotes at pi half and negative pi half. And the graph of like this is something like this guy. So this is y is equal to tangent of x. And that is the point pi half, and that's the point minus. So x equal to pi half and x equal to minus pi half are vertical asymptotes. And sorry, I have to remove this equality because x cannot be equal to minus pi half and pi half. It's strictly between minus pi half and pi half. Okay, so I was telling you that the range of tangent, if you see, is the whole real numbers from minus infinity to infinity. So that means the domain of arctangent is from minus infinity to infinity. Okay, but let us look at some sample values. So if what is the arctan of 0? Find an angle whose tangent is 0.
0.
How about arctan of √3? So what angle is
Pi over 3.
pi over 2? Because tangent of pi over 3 is sine of pi over 3 over cosine of pi over 3 is √3 over 2 divided by 1 over 2 is just root. And you can have more values like let me just write this. For √3 it's pi over 3. How about 1?
Pi over 4.
And because tangent is odd function, arctangent is also odd. So it's for -1, you have minus pi over 4. And for negative √3, you have minus pi over 3, and so on. But when x goes to infinity, arctan goes to what? When x approaches infinity, arctan approaches
pi over 2.
pi over 2. And if x goes to negative infinity, arctan approaches negative pi over 2. So it's basically inverse of this. So the limit of, so we know that so since the limit of tangent of x goes to pi half from the left is infinity, then that means limit of arctan of x when x approaches infinity is pi half. And the similar thing you can say about minus infinity. So I mean more precisely, limit of tangent of x when x approaches minus infinity from the right hand side is minus, for x approaches minus pi half, sorry, is minus infinity. So that means limit of arctan of x when x approaches minus infinity is minus pi. And I can also finally draw the picture for arctan. So you remember tangent, it has two vertical asymptotes, right? But for arctan, you have two horizontal asymptotes. So the vertical asymptote is replaced with the horizontal asymptote. And you have horizontal asymptote at y equal to pi half and y equal to negative pi half. And the graph of arctan, this is the graph of arctan. It looks like something like this. And these two lines, the horizontal asymptotes are basically y equal to pi half and y equal to minus pi half. Okay. All right, so here we learned inverse of trig functions. So make sure that you study this and you understand the meaning of these concepts and these functions, okay? So a good example. So, or you can say exercise, is that, so I define the Chebyshev polynomials. Chebyshev is a name of a Russian mathematician, I guess. Chebyshev polynomials are defined by, so Tn of x is defined by cosine of n times arc cosine of x. N equal to 0, 1, 2, 3, and so on. So here you have lots, like many polynomials, T1, T2. Each of them is a polynomial, okay? So first, try to find, T0, T1, and T2. And B, part B, prove that Tn plus 1a, Tn plus 1 of x is equal to 2x times Tn of x minus Tn minus 1 of x. This type of formulas that I wrote here are sometimes called recursive formulas. Recursive or reduction. So recursive means, what recursive means? It means that you define something in terms of, so like you have a sequence of objects like numbers, functions, and you define the sequence in terms of the previous values. Okay. So let me tell you something about recursive formulas. It's because it's an important concept in the whole math and also computer science. So forget about these trick functions. Just consider, so I want to define a sequence by this formula. So Pn plus 1 is equal to 2 times Pn. And I know for n equal to 0, 1, 2, and 2. This is a recursive formula. That means, so for each time you have a new term of a sequence, you defined it in terms of the previous terms. And I also have to tell you the first, and we know that P0, for example, is 10. It doesn't matter. Any number it can be. So what is P1? If you apply this formula, what is P1? So let n equal to 0. Apply the recursive formula. So let n in the recursive formula, let n be 0. So then that means P1 is equal to 1. To what?
$20.
It's 2 times P0, right? Which is 20, of course. But what is P2? P2 is 2 times P1, which is 2 squared times P0, right? And P3 is 2 times P2, which is 2 to the power 3 times P0, and so on. Can you tell me the general formula for PK? So in general, PK, the kth term would be 2 to the power k times P0, right? For example, P10 is equal to 2 to the power 10 times P0 is equal to . So this is a very important example. So this example is called the exponential growth. So it can be a model for the growth of a population. So after each year, this model tells us that after each year, the population gets doubled. So like the population after 1 year is 2 times the initial population, and so on. This is called exponential growth. Okay. Okay, so I just wanted to introduce you this concept of recursion, or sometimes it's also called reduction, by a simple example. Okay. Now, this is more complex recursive formula, because first of all, it's about functions and it's more involved. Okay, let's go back to our original question. So I want you now to find T0, T1, and T2 of X. Just plug in n equal to 0, n equal to 1, and n equal to 2 into this formula. This formula. So for example, T0 of X is cosine of 0. That was simple. So I answered this immediately. T0 of X is cosine of 0, because 0 times anything is 0. So that's easy to compute. Now you tell me, what is T1? T1 of X is cosine of, when n is 1, you just have arcs cosine of X. So what is cosine of arc cosine of X?
Cosine X itself.
What is cosine of arc cosine of X? So by definition, if arc cosine of X is theta, so by definition, that means cosine of theta must be X. Right? So if this guy is theta, that means cosine of theta is X. That is the definition of arc cosine, basically. Does it make sense?
Yes.
So that means cosine, therefore cosine of arc cosine of X is just X. So that means T1 of X, which is defined by this cosine of arc cosine of X. T1 is also X. So T1 of X is equal to X. Now, I want you, this is a little bit harder. Find T2 of X. Do it now. So we found a formula for T2 of x. T2 of x by definition is cosine of 2 times arc cosine of x. And we saw that T2 of x is just 2x squared minus 1. Now let's try to find T3 of x. T3 of x is equal to cosine of
3.
3 times arc cosine of x. Again, we assume that arc cosine is theta. So as if arc cosine of x is theta, that means by definition, x is equal to cosine of theta. Okay, so that means T3 of x is cosine of 3 theta, which is equal to cosine of 2 theta plus theta. Now, can you tell me the formula for cosine of a plus b? So anyone remembers this formula? What was cosine of a plus b?
Cosine A cosine B minus sine A sine B.
Perfect. So you just need to use this formula. So for cosine of 2 theta plus theta. So that means this is equal to cosine of 2 theta times cosine of theta minus sine of 2 theta times sine of theta. And we also know that, by the way, cosine of 2 theta. So you can either use the previous result, because we know that cosine of 2 theta in terms of the x, if x is equal to
2x.
cosine of theta, it's just 2x squared minus 1. You remember this result here?
Yes.
So if x equal to cosine of theta, then cosine of 2 theta is 2x squared minus 1. So either you can use this result, or you can just again do it everything again that we did. I mean, but here because we just did this, so I just use this result. So this is equal to 2x squared minus 1. And then cosine of theta, it's by the definition x minus, here, what is sine of 2 theta? Sine of 2 theta is just 2 times sine theta cosine theta, right? So here you get 2 times sine theta cosine theta sine theta. So it's 2 times sine squared theta cosine theta. Because this guy, sine 2 theta is 2 times sine theta cosine theta, right? And again, you can say that sine squared is 1 minus So this guy is just 1 minus cosine square of theta. So here you have, this is equal to, I just rewrite 2x squared minus 1 times x minus 2 times 1 minus cosine square of theta times cosine of theta. Right? And finally, eventually, again, we know that cosine theta is nothing but x. Therefore, this would be equal to 2x squared minus 1 times x minus 2 times 1 minus x squared times x. Right?
Yeah, I see, I see.
So which would be equal to, so you have 2 times x cubed, and then you have minus again 2 times minus x cubed. If you simplify, you would get 4 times x cubed, and then minus x, sorry, x, this would be x cubed. I guess it's minus 3x. Okay. Questions. So one of the questions on some other question, which is a review question, is find a cosine function with an amplitude like 5/4 and period of 6. So f of x is equal to, so the amplitude is 5/4. So you have 5/4 times cosine of what? So we know that the period is 6. So that means, because the period is 6, so you have 2 pi over 6 of x. So you remember, if the period is t, then you have cosine of, so in general, if the period is t, then you have cosine of 2 pi over t x. But here the period is 6, so you would get 2 pi over 6. Right?
Yeah.
So what if here, so that's it. So that means f of x is 5 over 4 cosine of 2 pi over 6 times x. Now, what if I tell you that you have also a maximum point at x equal to 1? And so what if x of maximum is equal to 1? So in general, you remember that I told you f of x is equal to a times cosine of 2 pi over t times x minus x of maximum. And of course, we can also have a c, which is the center of the midpoint. But here, I don't want you, so I don't care about the c. But that's the general formula for a sinusoidal function like cosine. So if x of maximum is 1, that means f of x would be so exactly similar things, except you have 2 pi over 6 instead of x, you just have x minus 1. Because maximum, x of maximum is 1. That means when x equal to 1, so this function attains its maximum. Okay, guys?
Still a bit confused.
About what part?
The maximum, like, what x maximum mean?
So x of maximum means, so in this picture, if you have a cosine or sine function,
Oh, like the highest point. Oh. Okay.
oh, so each of these peak points are could be a maximum. I mean, imagine this is also the x-axis. This is also x of x. For example, if you have a function like, f of x equal to cosine of 2 times 2x minus 1. Okay, and that means this is f of x equal to cosine of 2 times x minus 1/2. Now here, x equal to 1/2 is the maximum. Oh, the 1/2, I wanted.
Okay.
So what is the period of this guy? Now my question, this function that I just wrote.
X max 1 minus X max 2
No, period, not amplitude, the period.
period.
So this guy,
From the highest to, yeah,
so this guy is 2 pi over the period t. So that means the period would be pi. Okay, guys?
ah,